Hi everyone, and this is me again on Extrasolar planets. This time I'm going to tell you on how the type of planets found changed a little bit over time and why, and what are we looking for now, okay? Because before it was all about finding planets, now we have a specific thing that we are looking for. And when I say we, I don't mean all the scientists, because there are people that actually do this for passion, but there are other interests or other people that don't particularly find these extrasolar planets so interesting, but they have other interests, okay? So we have several ways of detecting extrasolar planets, all right? And the ones they are the most, the ones that we use the most are the Doppler or radio velocity, the transit method, and the gravitational microlensing. This list is of course outdated by now, and all these links are in previous videos in this playlist, okay? So when I talk about Doppler, radial, and all that stuff, there are these videos, they are included there, okay? So these techniques were very successful. I mean, radial was very, very successful. That's how we found the first planet, and the idea works great. Then we had Kepler, the Kepler mission, that went to look for the transit methods. And then, of course, the gravitational microlensing is now something quite big. And what happened was, and I'm going to include this video on the description, what happened was that the type of planets that we are finding start to change. In the beginning, all planets that we were finding were very different to what we would expect. So please watch this video on the, it's quite fun, it's a song, and you know, it is actually entertaining, but the science there is completely correct, and it does tell you the story of how the search of extrasolar planets changed over the years, okay? So we went, because of the techniques that we use, we went for planets like hot Jupiter, so very close to the host star and very, very massive, to cold Neptune, so a lower mass, but not so close to the star. And now we are finding super Earths, and this is where the interests start to increase. Because we are like, can we get a planet within the habitable zone, the zone that we can have liquid water, and can we then, you know, harbor that planet? Can we go there and use that planet, okay? And the habitable zone does change according to the type of star you have. If it's a red dwarf, obviously it's closer to the star. But if it's going to be a supergiant, a blue star, or you know, a kind of a white star, is going to be further away from the star. So people started to look not only, or to target not only planets that would be at certain distances, but we also started to target within the Milky Way. Because the planets we were looking for, they were like in a tiny small region, and now they're saying, okay, this is the limit where we could harbor life in terms of extrasolar planets. Too close to the center, where we have a supermassive black hole, there's lots of stars and collisions, so you know, we could not really get life there. And too far away, then there are not enough stars really. So we are going to focus our search within a certain space, okay? And then we did find the TRAPPIST system, the one that if you go on my first video about the direct imaging, on where NASA asked people to you know, try to name the planets. And by the way, many of these pictures, of course, they are not mine, I'm just using them on the PowerPoint. And some of these planets are actually in the zone that is interested to us, or that is of our interest. So then the search for extrasolar planets stopped to be, or people, and I don't mean the scientists that really care and really love extrasolar planet hunting, but people started to be more interested around potentially habitable extrasolar planets. So the ones that may be like super Earths, so the ones that have a size around the order of the Earth size, where we could potentially go there if we were in this one. So in this picture is the worlds that we have that could not only are rocky planets and around the size of the Earth, they could, please look at the the comparisons, they could harbor life because they may have the components such as liquid water that we need to harbor life, okay? On the other hand, there are some really interesting planets that we have found. There is, for example, a planet that the atmosphere is boiling off. So this is now going to the more different planets. The atmosphere is boiling off because it's so close to the star. So this planet in particular circles the star in 15 hours. Each 15 hours is going to be 1 year in that planet. That's amazing. There are other planets. There is one that it has a backwards rotation, which makes no sense whatsoever to us in terms of conservation of angular momentum. There is a planet that seems to be made all of diamond. It looks like at least 2/3, I think, of this planet is going to be all diamonds. There's other planets. There seem to be quite strange. There is one that is about 13 billion years old. So, where did that come from? Are we right about the Big Bang? Another one, there is one planet that always have rain of glass going sideways. Okay, so can you imagine raining glass on that planet? There is the other one rains diamonds, for example. Another one that orbits the star backwards, and another one that is quite dark, you know. So they are very, very interesting planets. In the beginning, it looked like the solar systems we were looking at were very different to ours. Nowadays, with the improved in techniques in terms of finding extrasolar planets, it looks like our solar system is more or less what most solar systems should look like in terms of number of planets and distances towards the stars. But there is, again, I don't have enough information to actually say that this is the reality, but this is what it looks like at the moment. And there are also other planets that are very rare, very strange. So this is it for, at least for a while, all on extrasolar planets. So the playlist is now completed until something else makes me to add something else or something new. So up to my next video, which probably is going to be GCSE revision. Be happy and healthy. Bye!